So hey everyone, welcome back to another video. And today in this video, we are going to discuss the problem minimum remove to make valid parentheses. So this is a lead code medium question. Let's discuss. So given a string S of opening parentheses, closing parentheses, and lowercase English characters, your task is to remove the minimum number of parentheses in any position so that resulting parentheses string is valid and return any valid string. So there are some rules that are given for validity of string. If it is empty string, it is valid and containing only lowercase letters, it's valid. Secondly, it can be written as A concatenated with B. That means there is a parenthesis, closing parentheses. So in between there is something A, B, C, D, right? This is also valid. Thirdly, there can be a single character also in between parentheses. That is also valid. So the main thing is to complete the parentheses pair, opening and closing, right? So to make this valid, we need to do like that. So let's deep dive into this problem. So let's discuss some example test cases. So here is the example one that is given as Leetcode, and it has some set of lowercase English characters. So let's skip them because they will always be added in our answer. The main thing is we want to focus on these parentheses only. So let's write them separately for now. These are the parentheses that are given to us. Now we can see this is the complete pair. This is also the complete pair. This is extra. So we can remove it. Now the thing is, for these two can also be taken, these two can also be taken, or these two can also be taken. But for simplicity, whichever comes first, we will take it, right? So we can remove it, right? So in this way, we can say that for this answer will be LEE, bracket T, bracket C, bracket O, bracket DE. So we have removed this part, right? So now similarly, for this, we can see that these two are completing the pair. So this is extra. So we can remove this A, B, bracket C, closed, right? Similarly, for this, we can see this is the closing and no one opening parentheses before. So that means these two should be ignored. Similarly, for these two, there should be closing parentheses ahead and nothing is there. So we can see this is just empty string. So yes. So from this, we can just directly observe that what we want to just complete this pair, right? That for there is a opening parentheses, then closing parentheses, and in between characters are just we will take. That doesn't matter. So now, if you just scroll down the lead code discuss section, you will find various approaches. But all the approaches just go behind these two approaches that we're going to discuss now. So let's discuss the observation behind first approach. So let's jump to the observation. So yes. So firstly, as I already discussed, that the closing, opening and closing parentheses for this pair is valid, right? Similarly, for this, there should be a closing parenthesis before, right? Like opening and closing. In simple words, we can say we want this pair only. Like this is not valid. This is only valid, right? So now let's take some example so I can explain better. So here you can see like we have already discussed this is empty answer. Why? Because there is a closing. But for this closing we need opening, but there is no one. So this should be removed. Similarly here for this there should be opening. This should also be removed. For this there should be closing after. This should be also removed. This should be also removed because there is no closing. So the empty string is the answer here. So similarly for this, we can see like there is a closing and there is a like opening and closing. So this complete the pair, but this is extra. We can remove it. Similarly for this opening, there is a closing. So we can remove it. Now we can also do this, right? But for simplicity, let's take first ones only and let's remove in between, right? So this is completing the pair. Okay. So it doesn't matter like this should be there or this should be there. We want to just take two brackets and complete the pair and rest of them. For example, for this, there should be a closing parenthesis after that. So if it is not available, then obviously we can say that it should be removed, right? So this is an observation, like simple observation. Now, one thing that I want you to observe that whenever such kind of things comes, like we have discussed many questions similar to these in string. So whenever such kind of thing come, like there is an opening and we want to complete this closing pair. So stack helps us. How, for example, let's say this is the part and we want to check if it is valid or not. So if I maintain a stack here, so we will add opening, opening and closing. So closing will say there is an opening. So let's remove it. This is valid. Similarly, there is again closing come. So it will say again, this is also valid because these two are completed. Now we can see at the end this left. So that means it's not valid. Why? Because these four have taken, but this is extra. There should be opening for that. So you can understand like in such kind of thing, the stack comes. Why? Because we want to complete some pair. So that is the intuition behind first approach. So we are going to use the stack. Let's skip this part for now. We will discuss later. Let's approach this using stack for, right? So I will tell you like why this star is useful. So let's create a stack which is initially empty. So this is a stack. Now in this stack, what we want to make the removals to make valid parentheses, and we want to make it minimum. But obviously, like this minimum doesn't matter for us. Why? Because we can see like if there is opening, closing, closing, and there is extra closing, so we will just remove them. Simple. So let's discuss using stack. So firstly, we will see this is L. So this question we will do in two iterations. So let's think about first iteration only, where we are going to just skip these characters for now. We will don't think about them, and we will just focus on these parentheses only, right? Because we want to check if it is valid or not like that, right? So in the first iteration, let's let's begin. So we will start the for loop. So here is L, just skip E, skip E, skip. So here you can see opening parentheses, right? So we'll say just add its index 3. You will get it later on like why we are doing this. Let's understand for now. T, skip it, opening parentheses, add its index. Like for every opening parentheses, add its index in the stack, right? Now here you will see C, O, skip it. We are not considering lattice for now in the first iteration. Now we will see closing parentheses. So closing parentheses at 8th index, right? Now we will check, is there any opening parentheses in the stack? Like stack will help us to determine there is a opening parentheses with us, right? At 5th index. So we can say that that 8th index is completing the 5th index. Why? Because this is a closing, this is opening. We are just completing this here. So we can say simply what you have to do, just remove this 5th index for now and just go ahead, right? Now, similarly, let's jump to the next iteration D, and there is a closing parentheses, right? Now we can see there is a 10th index. So again, we found there is a 10th index here, and there is a closing parentheses. So here we will just check, is there any opening parentheses which we can complete? So yes, this is also completed. Now we will say this we can complete now because index 3 index is here. So what we will do, we will just remove it and just go ahead, right? Like we are just going ahead whenever we found the complete pair. Now E12. Now when we come to 12, there is a closing index. Now here we can see that this stack is empty. Like stack is empty. What that means? That means there is no opening parentheses to complete. So this is not required. We need to remove it because obviously these two are done. Why we are taking this? So we will say what we can do is just mark it at star. So instead of this, mark it at star. Why we are marking it star? So as I already discussed, let's focus here now. Irrelevant character for us. This is irrelevant for us. Let's discuss like how it will be irrelevant that we have completed these pair. So this is just extra. Why we are taking this? So let's mark it at star. Now in the second iteration, what we will do, we will just traverse the string and whichever character is star, just skip it. Don't add it to our answer. So let's write it. For example, this is the answer. This is the answer variable. And in this answer variable, like we will add L, E, E, bracket T, bracket C, O, bracket D, star E, like bracket E. Now here we see star, just continue, skip it, right? So this is a valid string. Now let's take another example, another test case as well to better understand it, like how it will be helpful. So let's take another test case. For example, L, bracket E, E, T, C, O, bracket D, bracket E, right? And let's say this is also closing. So let's say this is opening bracket for now to create the better test case. So let's create it closing, right? So let's create the stack in the first iteration as we simply do. Just skip the characters. So let's skip these before only. Let's not concern over here. So we have closing parentheses. So we will just say like this is a stack. Now stack is empty. Now that means there is no opening parentheses to complete. So just mark it at star. So we will just mark it as star. Similarly, we will mark it as star because again stack is empty. Now when we come to here, let's say its index is 0, 1, 2, 3, 4, 5, 6, 7, 8. We will add this index. Again, we come to closing parentheses. So here we will see like this is a closing parentheses. So we need to complete this pair. So as we can see, inside there is a opening parentheses and we have outside closing parentheses. So we can complete it, right? So we will say just continue, like just remove it, like this, and this opening parentheses is used. And let's jump ahead. Now, when we come to this index, so we'll just 8, 9, 10, 11, 12. So we'll just push this index. And after finishing, we can see that stack has something like there is opening parentheses and no closing parentheses is used, like is not completing it, right? We are not pairing anything. So we can see like whichever thing is left in the stack now, like those who are opening parentheses and they are not yet completed. So this is the opening parentheses and it's not completed. So it will be remain in stack only. So no one is removing it, right? So we will just pop it out one by one and just mark them as star. And at the end, we will just iterate and find the string, right? Final answer, right? So now, what is the time complexity for this? Time complexity is big of n because we are just iterating 2 times 2n. So we can say big of n only. And what is the space complexity? Space complexity is big of n only because we are using stack, right? So yes, this is the time complexity, space complexity, and this is about the approach and intuition. So let's jump to the code for the approach one. Approach one. So here we are getting the stack initially, and here is the n, is dot length. Now we will iterate over it. Is dot length, like n only, I plus plus. Now what we will do, like if s of I, in the first iteration, we will just skip the characters and just focus on the parentheses only, right? So we will say if s of I is equal to opening parentheses. So we can just push the index of that because why index? Because from the index only, we are able to identify which is to mark as star or not. Otherwise, by just character, we can't identify it. We need to store the index, right? So in the else, we will check if stack is empty. For example, this is opening parentheses, we will just push and it's a closing parentheses. And if the stack is empty, that means there is no one to complete. For example, this is the, for example, this. So this index, there is no one here, add. So we can see like it's just not required. So we can say that just mark it at star so that it will be skipped in next iteration. Just mark this index as star. If the stack is not empty, then just pop out from the stack only, nothing else needed. So just pop out. Yeah. Now, as we already discussed, like there can be the time when only opening characters are left, opening parentheses are left. So in that case, what we want to do, we can just mark them as star because they are not completed and they're invalid for us. So while stack is empty, so we will say uh, index is equals to st dot top and s of index is equals to star and st dot pop. Now in the second iteration, let's create an answer variable answer string and traverse the string again. And whichever is star, just skip it. Otherwise, add it. If s of I is equal to star, just continue. Else, answer dot pushback s of I and just return the answer. We have not added this condition, yeah, because otherwise it will also take the lowercase character also. Let's run the code and again check whether it's working fine. Yes, let's try to submit the code. So yes, it's totally working fine. So now let's jump to the approach 2 of this question. So this is a counter-based approach, like you will understand like how it is counter-based approach. Now, in this approach, we are going to maintain the two variables. We are not going to use the stack. Like we will understand how we can solve this question in bigger of one space only. So let's take this string and let's understand. Then you will get the intuition later on, like how this is helping us. So let's add the index for now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in the first iteration, this will be also be done in two iterations only. So in the first iteration, what we are going to do, we are going to maintain the count of the closing parentheses. So here you can see like when we iterate over this string, so 1, 2, and 3. So there are 3 available closing parentheses. So we will just maintain it in a variable. Now, why it will be needed, I will tell you later, right? So let's understand the second iteration, like how in second iteration, this will help us. Now in second iteration, what we will do, let's create an answer string And let's, whenever lowercase character comes, just add it. Lee, just add it simply. Now the opening parentheses came. So now we will understand, like in the, like whenever there is a opening parentheses, what it want? It want the closing parentheses add, right? So whenever we want we want to know the closing parentheses, either we can run the for loop ahead, right? And increase the complexity bigger of n into n, like n for iteration. And for every n, we need to check the, is there any available closing parentheses? So let's run the smartly. What we can do, we can just maintain the count of available closing parentheses. Now, one question can come in your mind that, for example, this has used this has used this closing parentheses, and this again come. So it will also find one closing parentheses. So we'll say you can also take it. But obviously, this can only complete one. This can't complete both. Let me repeat again. For example, this closing parentheses, this opening parentheses, and there is a closing parenthesis add, and it has been completed. Now, this also find that there is one closing parenthesis ahead. So we will say like you can also take it. No. How we will handle it, you can understand. So let's understand. Now, for example, let's take closing parentheses. And here we can see there are three closing parentheses ahead. For this opening parentheses, there are three availability. So what we will say, just reduce it. Just make it two and take it. Because there is availability add. So just reduce it. That there is like one is lost now. It is used by someone. So the remaining are only two. So now, now in the close taken, we will increment this. Why? Because you have taken one close, right? So we will understand like how this will help us, why it is needed. So let's understand. So T will come as it is, as we said, lowercase English character, just add it as it is. Now again closing parentheses come. Now we will again ask, is there any available? Any closing parentheses is available? We will say yes, two are available. So let's make it one and let's increment it. That one close is taken and one is reduced. One is not available. So we have only one available. So we have reduced two. So we will just add here. So now C will come as it is. Now closing parentheses come. Now this closing parentheses. Now should I take it or not? How can I determine? I will determine using close taken. This close taken will help us. For example, uh, like anytime we want to understand, like is it needed or not? For example, let's skip. There is nothing, and we just directly come to this. So do I take it or not? How can I understand? If there are before any opening parentheses, then only I will take it. Otherwise, why should I take it? It is not completing my pair. So using this close taken variable, we have two. That means we need to do it two closing parentheses. So from this, we can understand this variable is useful. So you have understood like why useful. Available close will help us to determine how many are there. Close taken, it's very simple to understand. Like close taken is just like how many opening are taken. That many opening are taken, let's say two. Two are taken, so two close, two be taken. We need to take two closing variable, two closing parentheses, right? So let's take it and let's reduce it. Now just add O as it is. Again, closing comes. So do I need to take it? So we'll say yes, take it. So let's take it, make it 0. Now no closing to be taken. So DE. Now let's come to here. Now this will help you to understand more broadly. Like this is closing. Do I need to take it? No. Why? Because this has also been completed. This has also been completed. There is no one ahead. Why should I take it? How we can understood? We can understand by close taken variable. This will help us to determine that many close are to be taken. So two are taken. This is not needed because it is 0. This is not needed. Just skip it. Also, what you need to do, you need to reduce this available closing variable. Why? Let's take another test case and let's better understand like why this available closing is needed to be reduced. For example, let's say L E T C bracket O D bracket E. So here you can see, like in the first citation, we will again calculate available closing, and that is 1, 2, and 3. So let's make it 3. Now close taken are currently 0. So let's iterate over it. In the first citation, we have counted the available closing, LE. Now we will take this. Now we can understand like these two are closing variable and close taken is 0. That means this is not to be taken because there is no one ahead. So why should I take it? Similarly, for this, there is no one ahead. Why should I take it? So I will not take it, right? So we will say, just skip these two, right? So let's do one more thing in this test case. Let's remove it. So now available closing, let's not reduce it and let's keep it three only. For now, let's not reduce it and just skip them because they are not needed because it is zero, so we don't need to take it. So T, C, now closing comes. Closing asks, like it is two actually because I have reduced one. So it is two. Now this opening will ask, is there any available? I will say yes, but actually there is no one available ahead. So that's the reason we need to reduce them as well. So when it is zero, because if I've reduced it here only, then I will be able to understand like for this opening, there should be a closing and which is not available ahead. This is not available ahead. So we will say just skip this as well because there is no one to complete the pair. So this is the idea behind approach 2 that we need to maintain the two variables available closing and close taken. Available closing will determine ahead closing parentheses. We can name it like that as well. And close taken are how many I need to take or close to be taken. You can give it any name as per your preference. So what is the time complexity of this approach? Time complexity of this approach is big O of n, like big of 2 and big of n, one and the same thing. Now, what is the space complexity? Is big of 1 because we are not using stack. We are just maintaining two counter variable and it's just constant. So this is how we reduce the space complexity as well. So let's jump to the code of this approach. So let's discuss the code for the approach 2. So as we discussed, we have two variables available closing is equals to 0, close taken is equal to 0, right? Now in the first iteration, let's maintain the insert length. And whenever we find if s of I is equal to closing, then available closing plus plus. Now we will again traverse this string. Now we will ask, is s of I is equals to opening parentheses? Second case, if s of I is equal to closing parentheses. Third case is just lowercase letter. So here is a variable, answer variable. So we will just push back s of I, right? Now, whichever character is lowercase character, we will just push back that into answer. Now for every opening parentheses, we will ask like, is there any available closing ahead? If yes, then reduce it because it has been taken and just make it that close taken is plus plus. Also, one more thing that don't forget to take this s of I, like opening parentheses, don't forget to take it, right? Now for closing, we will ask, is close taken is greater than 0? Like, is it needed? Like, if it is 2, that means we need it because there is already opening parentheses add. Now it's the time to take closing parentheses, right? So we will just say like answer dot pushback s of I. Now, don't forget to subtract the close taken also. Close taken minus minus. So in the else case, we will just check. Now, obviously, available closing will be greater than 0 only because obviously it is here. That means there is a closing variable. So we will say directly just subtract it because it is no more needed and add then just return the answer. So now let's try to run the code and check whether it's working fine. Yeah, let's submit the code. So yes, it's totally working fine. So this was all about these two approaches. So if you like the video, please like, share, and subscribe to the channel. Thank you and have a nice day.